All right, hopefully everyone joined. Hi guys. I've selected a few uh, exercises that could be potentially in the midterm or similar to those that are usually in the midterm. Uh, let's start it. Uh, the first one is from last year's midterm. Uh, how many integers are there between 1 and 10,000 whose last two digits in the decimal system are 34 and whose last digit in the hexadecimal system is E. And the E hexadecimal system is based on a base of 16 and E denotes to the digit 4 in it. So let's start with what does this question mean. So basically they ask you how which numbers are which numbers, which let's say n, which n numbers congruent with 34 modulus 100. This comes from this part of the question because every number that ends with 34 congruence with 34 when you are dividing it by 100. And the other part of the question is that last digit in the hexadecimal system is E. So basically, it also needs to be congruent with 14 because E equals 14 in the hexadecimal system, modulo 16. That comes from the fact that that system is based on 16, which numbers can be divided by 16. So every number that has that last digit is E, congruence with 14. And from this one, we can write that n equals 100 times k, where k is a whole number, so any integer basically, plus 34. This is always true. So for example, k is 0, then n equals 34, and 34 congruent 34. That's true. N equals 1. 100 times 1 is 100 plus 34 is 34, and then but 100, so 134 congruence 34 modulo 100, because if you divide it by 100 you get 1 and the remainder is 34. Yeah, and we get this equation, and we put this into this equation. So like 100k plus 34 congruence 14 modulo 16. This must be true. So to find those numbers that are those whose last digit is 34 and E in the hexadecimal system, both this needs to be true and also this needs to be true. So we need to solve this equation. So next page. So 100 k plus 34 congruence 14 modulo 16. So by the rules of congruences, you can add, multiply, and subtract from the congruence, and it will stay true. You can also divide them, but you need to be careful when dividing, because when you are dividing by a number, you also need to divide the modulus by the smallest, largest common the lowest common divisor, the modulus. So yeah, you can basically add, subtract, multiply, and divide, but division is a bit tricky. But right now we only need to subtract the 34 from both sides of the equation. Let's call it that, and we get 100k congruence minus 20 modulo 16. First, we need to check if this is solvable. How we need to do that is we need to check the lowest common divisor of 100 and 16, which is 4. You can do this by basically dividing the number into prime numbers, so like 100, 2, you get 50, 2, 25, so 25. You can divide this by 2, so you look at the next prime number, 3, you can't divide it by 3, so you look at the next 5, you can divide it by 5, you get 5, you write down 5, 5 and 1. Hopefully everyone remembers this one. This basically 100 equals 2 to the power of 2 times 2 to the power of 5 to the power, I messed up, times 5 to the power of 2. 16 is, well, 2, 8, 2, 4, 2, 2, 2, 1. So 16 can be written down like 2 to the power of 4. And you check the common parts of the two equation, and you get 2 to the power of 2, which is 4. So the lowest common divisor is 4. Alright, we got the lowest common divisor. Now we need to check if 4 is the divider of so 4 is a divider of 20, which is true. So this equation has a solution. Now we make this equation simpler. So we have right now 100k congruent minus 20 modulo 16. We know that it's solvable. Now we need to make it simpler to solve it. You can write it down like this for k congruent 12 modulo 16. Why can you do that? Basically 100 is equals 6 times 16 plus 4. From that we can basically take away the 6 times 16 because it will give 0 as when dividing by 16, and the remainder is 4. So 4k equals 16. Why? 16, I messed up, not 16. This is 12. And why 12? Well, minus 20 plus 16 equals -4, -4 plus 16 equals 12. You can do these steps because they basically represent this, will always make the congruent true. Because -20 and -4 is both congruent modulo 16, and -4 and 12 congruent modulo 16. These are the steps to make a congruent simpler, so you don't always need to work with huge numbers or negative numbers. These are always steps that you can perform. Alright, we now have 4k congruent 12. So now comes the tricky part. We want to divide by 4. What happens when we divide by 4? First, we need to check the largest common divisor of 4 and 16. The largest common divisor is 4 and 16 equals 4, obviously, because 16 is 4 times 4 is 16, so yeah. Now, when we want to divide this whole equation, we divide it by 4, we get k congruent 3. We also need to divide this by 4, which is 4. Alright, from that we get that k equals 4 times L, where L is an integer, so any integer that you can get, plus 3, and this is a equation of how you get k 4 times a positive integer plus 3, and it will always you will always get a number that's congruent 3. So when dividing modulo 4, so when dividing it with 4, the remainder will always be 4. So very good, we have this equation and we had this equation. What do we do now? Well, we write it back. So we have 100k plus 34. This is n. And we write it back, so it will be 100 times k, we varied, so 4l plus 3 plus 34, which equals obviously 400l plus 334. So what do we do with number? Basically, this is equation. This is an equation for every number, which is less 2 digits is 34, and a in hexadecimal. Why is that? Because we obviously have this equation. This makes this equation. This so this equation. This makes sure that the last number is always 34, and we have this equation which makes sure that it's modulo it's a in the hexadecimal. We combine the two together and we get this equation which combines the two. So there will always be a number that last number is 32, and at the same time a in hexadecimal. Now the other part of the question was which numbers are there which are between 1 and 10,000. For that to find out, you have to try which numbers are those. 1 obviously is 2, 3, and by that L can be 1, 2, many numbers, and if you put give me a second 24 in, so 400 times 24 plus 334 equals, give me a second, 990. So this is the last number. 24 is the last number that is still between 1 and 10,000. So the L can be 1, 2, and 24. To find this, you just have to try a few numbers. Like you can usually it's first like try 10. If it's bigger, then go lower. If it's smaller, go up again. It's based on how far away are you from the uh, uh, bigger from the number that you want to reach, and yeah, it sadly you need to try a few numbers for that to find out. Now I just wrote down 24 because I had the answer, but yeah, this is how it works. So yeah, any questions with that, with this problem, or was it clear?
Why did we use 100?
Could you repeat, sorry?
Why did we use 100?
100. So you mean here or here?
Yes.
Because the last two digits are 34. For that to find, we have to use 100 modulus, because when you divide something, divide the number by 100, you get the remainder will always be the last two numbers, because the other part is always divisible, and the last two numbers will be the remainder of this division. For example, if you wanted to find the last digit of a number, you need to divide by 10, and the remainder will be the last digit. If you want the last digit, you need to divide by 1000.
Okay, thank you.
You're welcome. Any other question?
Can we go to second slide?
Yeah, we can, second problem or second side?
I mean second slide.
This is
Not this one. No, not this one.
this
From the first. No, back then.
here.
No, after that. This one after that.
Hmm. There is no second slide. I don't know what do you mean by second slide.
After this, when we have solved like 100k equal to minus 20 mod 16.
Oh, 100k this, or
No.
then this.
Yeah. I have a question like from
Alright.
the first there is like 100k is congruent to minus 20 mod 16. Then you suddenly got like 4k is congruent to 12. Like if you divide the 100k by like let's say like 25, you have to divide like on the side by 25, like on the right hand side also.
Sorry, repeat. Could you repeat? Or well, we actually no.
What would be?
I think I understand what you mean. Right now, we are not actually dividing. I used the wrong word. It's we are.
Oh, I got it.
So you got
It's
it.
like 16, 16 into 6 times 16, 6 and 96, I guess.
You get yeah exactly. So like 100, 100 is congruent 4 modulo 16, so that's why we can use 4, because 100 is 6 times 16 plus 4, and it's easier to use that. But basically, you can also say that you are subtracting 16 until you get a number smaller than 16. So like 100 minus 16 minus 16 minus 16 minus 16 minus 16. So basically 6 times is 4, and which is smaller than 16. You can actually divide, subtract one more times, but it would be like negative, so it wouldn't fit for us. But 4 is the perfect. 4 is perfect because we can change the other number to make the whole equation divisible.
Okay, thank you.
You're welcome. Any other questions? All right, then next problem, next exercise. Give me a second. Where is it? So decide if a number is number below is integer or not. So first, what does this question ask us? Whether or not this number is integer or not. How do we decide that? The question is, if 5 times 2, 7, 9 to the power of 9, 6, 1 plus 5 divided by 1014 is something, and the remainder is 0. Or in other words, 5 times 2, 7, 9, 279 to the power of 961 plus 5 congruent 0 modulo 1400. And as you can see, when there is a very big number, a number on so something to the power of, and the power of is quite a big number, that's usually Euler-Fermat thesis most of the time. But you need to check whether or not you can use Euler-Fermat or not. How can you decide that? So the first rule of Euler-Fermat is that the modulus, which is 1400 right now, and the number, or the sums, let's go the 279 right now, or the number, these two smallest common divisor is 1. That's the question. If not, then you can't use Euler-Fermat. If it's 1, then it's free to use, and usually it's the right choice. So how do we find that? First, to see what the smallest common divisor is. First it's 2, 700, 2, 350, 2, 175, then 5, 35, 5, 7, and 1. Hopefully everyone knows how to do this, because it's quite a big part of this midterm. Basically dividing a number into prime numbers, the multiplication of prime numbers. So that means 1400 equals 2 to the power of 3 times 5 to the power of, I messed up. So the 5 to the power of 2 times 7. And 279, you can't divide it by 2, so you try 3, which you can. It's 93. You can again 3, 31. 13 is a prime number, so 31, 1. So 279 is 3 to the power of 2 times 31. You can see that there is no common number, so basically that means that it's true. So 1 is the smallest common divisor, or the largest common divisor. Largest common divisor. Sorry. So that means we can use Euler-Fermat. What does this mean? So we can use Euler-Fermat. There is the Fermat function phi. This first we have to find the phi of the modulus, so 1400, and we already know what the prime number prime number multiplication is from this. So you know that it can be written like this, so 2 to the power of 3 times 5 squared times 7. And there is a thesis which says that this can be calculated by basically taking the prime numbers and taking one away from the power of, so 2 to the power of 3 minus 2 to the power of 2. You multiply this by 2 to the power of, by 5 to the power of 2 minus 5 to the power of 1, and you multiply it by 7 to the power of 1 minus 7 to the power of 0, which is like this whole sequence equals 480. But basically you need to calculate 2 to the power of 3 is 8 minus 4 is 4. 25 minus 5 is 20. 7 minus 1 is 6, and 6 times 20 times 4, 480. So we got the phi 480. Now, thanks to that, we know that, and the Euler-Fermat thesis that 279 to the power of 480 is congruent 1 modulus 1400. So why is it good for us? It's very long. It's very long away from this number, or even this. But we can use this to get to the original equation. We can put it on the power of 2, which we can do, and the congruent and it will stay true. So that means that 279 to the power of 960 congruent 1 on the power of 2, which is 1. modulo 400. So that's still true. Now we can multiply it without any problem. So let's multiply it by 279. So thanks to that we get 279 to the power of 961, because obviously 279 to the power of 960 times 279 is just adding +1 to the power, and 1 times 279 is 279 modulo 1400. Now we can also multiply it by 5. So 5 times 279 to the power of 961 equals 5 times 279, which is given a second, 1395 modulo 1400. And then we can add the +5, because obviously we want to make this one look like the original, which is this. So 5 times 279 to the power of 961 plus 5 equals 1400 modulo 1400, but 1400 modulo 1400 is 0, because yeah, there is no remainder when you divide a number by itself. And we basically solved the problem, because this, so this is congruence with this. So that means 5 times 279 to the power of 961 plus 5 divided by 1400 gives no remainder, so it's an integer, a whole number. So yeah, you can use Euler-Fermat, and it's pretty simple. There is usually, there's almost always a Euler-Fermat. So it's important to learn, but don't use it without actually checking whether or not you can use it. There are the rules when you can use certain methods. Always check if the if the rules allow it. Any questions? All right, so I need to make a new call, because in 14 minutes it will be over. So we will be back in a minute. I will send you a new link. All right, so here is the new link. Sorry, Google Meet only allows for like 45 minutes. Thank you very much. So please meet me there. Yeah, see you there. It's in the course chat. All right, I think everyone Everyone joined, good. Presentation, this one. All right. Ati, can you send the new link to the WhatsApp group? If someone want to join, thank you. So then, is there any question with the second exercise?
On the second slide, why did we say 7 raised to power 1 minus 7 raised to power 0?
So this is how we calculate the Euler function, which is the phi function. It's this funny or like symbol. Give me a second. I will. So there is a formula which says the phi n is equals to prime 1 to the power of k. So giving you enough. So n is the number that we are looking for. So in this case it was 1400, and the formula says that p1, which is prime 1, it's always a prime number on k1. It's basically any number, but to the power of something, minus p1 to the power of k1 minus 1 times p2, it's a second prime to the power of k2, the power of the second time minus prime 2 to the power of this k2 minus 1. Sorry. So yeah, and this continues to until p n, that means p r, that means r number of primes, so it can be any number k to r. So this primes power of minus p r to the power of k r minus 1 equals the phi. So it's basically a formula which says if you have a numbers prime number prime factor, yes, prime factor, then you can calculate the phi by putting it into this formula. It's basically just you have to learn it that every number's power minus itself to the power of minus 1. Yeah, that's why we put it here 7 to the power of 1, because 1400 is 2 to the power of 3 times 5 to the power of 2 times 7, and this, if you calculate it, will give you 1400, and it's only prime numbers, so we did a good job. And then putting it into here, you can calculate with that the phi, which is then used for the Euler-Fermat, which says that a number to the power of phi congruence 1 modulo m, or in this case 1400, which is the phi's original value. Hopefully this helped.
Yes, thank you.
You're welcome. Any other question? All right, then the fourth or the third problem that I wrote down. So using the Euclidean algorithm, determine all the integers between 0 and 301, which when multiplied by 222 give 34 as a remainder when divided by 302. It sounds complicated, but they basically are asking that which are those numbers that when so which x's when multiplied by 222 congruence 34 modulo 302, and this will come in the later stages. So currently we are only focusing on this part. So the task includes documenting the computation as well. So it's not just like you calculate it somehow and then write down the answer. You need to write down every single step of the equation of the algorithm. So when using Euclidean algorithm, first you need to calculate 222 and 302's largest common divisor, because then if you have it, then you have to divide the whole equation with it. So to calculate this, you need to write down the 203, so the bigger number always, then equals 222 plus something. So something times 222 plus something. First you have to check how many times you can subtract 222 from 302 and without going into minus. That's 1. So 1 times 222 is 22, but 1 times 222 is 222, and then you write down the remainder, which is 80. So if you calculate it, 80 plus 1 times 222 is 302. So yeah, basically you write down this formula. Then you take this, you put it here, so 222, and you put this here, 80, the remainder here. You check how many times you can subtract 80 from 222 without going into negative. It's 2 because yes, it's 2. And the remainder is 62 because 2 times 80 is 160, and 222 minus 160 is 62. Alright, you got to here, then you basically continue this until you get to 0. So the 80 comes here, and now 80 equals to 62. Something times 62, it's 1 because you can only subtract 62 from 81s, and the remainder is 18. Now 62 comes here, 18 comes here. It will be 3 because you can subtract 18 from 62 3 times. The remainder will be 8. Then 18 comes here, 8 comes here, it's 2. Remainder will be 2. Then 8 comes here, and 2 comes here, and 4 times 2 is 8, so the remainder is plus 0. We got to the end of the algorithm. Then we get this number. This remainder will be the largest common divisor. It's 2, so we get 2. All right, we got the largest common divisor, so 222 x congruent 34 modulo 1000, but not 1400, is the last one, module 302. And with this largest common divisor, we have to divide the whole equation with it. It's the rule when using the Euclidean algorithm. So divided by 2, you get 1 on 1x congruent 17 and modulo 151, because you also need, when dividing congruent, you also need to divide the modulus with the largest common divisor, which in this case is 2, so 151. And then after we got here, we have to continue the equation, the algorithm. So let's say this star is 200 and not 200, but sorry, 151. So here this x congruent 0 151. This is always true because yes, any number times 161 will be divisible by 151. And let's say a b, call it b, is this one. So 111 times x congruent 17 modulo 151. So the second one will be always the one that you calculated. The first one is something that you write down as always true. So yeah, the modulus times x is always congruent 0. That's you always write down, and then you start to continue the algorithm. This time it's x minus, you see, minus 1 times the b. So what? And let's call it 1. And this will be something like 151x minus 1. So this is why the 1 times b minus 1 times 121x congruent 0 minus 1 times 17, and the modulo 151 comes here. So from this we get that 1, the 1. So the equation named 1 is, give me a second, I will tell you, 40 x, because 151x minus 111x is 40x, congruent minus 17 modulo 151. Alright, we got the one, and now we shift this equation a bit. So instead of the star, it will be b minus 1. So this equation. So the b equation is 111x congruent 17 modulo 151. The number, the one equation is 40x minus 17. Well, 40x congruent minus 17 modulo 151. So we have to check how many times we can subtract 40 from 111. And it's, give a second, it's 2. Because 2 times 100, 2 times 40 is 80, 3 times is 120, which is more than 111. So 2 times the number 1 equation, and we will call it 2. So this will be the second equation, number 2 equation, and it's basically then 111x minus 2 times 40x congruent minus 17 minus 17, not minus, so minus 17, because this is where it comes from, minus 17 minus 2 times minus 17, and so 151 goes here again. So that means that 2 will be 31x, because 111 minus 80 is 31, congruent 51, because 17 minus 2 times minus 17 is 17 plus 2 times 17, which is 51, modulo 151. Basically, we are doing this until we get to x. So right now we have 31 x congruent 51 modulo 151, and now we subtract from the number 1, so this equation minus the second equation, x many times, 40 minus 31, it's like we can only divide, subtract once. We will call it 3, and basically then it's 40x minus 31x congruent, was it the second, it's the first one, minus 17 minus 1 times 51 modulo 151, and this means that the third one will be 9x congruent minus 68 modulo 151, and now we take the so we subtract from the second equation, which is this, minus the third equation, which is this, 31, and 9 you can subtract 3 times 9 before you go to negative, so 3 times the third equation, and we call it the fourth, and basically it's 31x minus 3 times 9x congruent 51 minus 3 times 6 minus 3 times minus 68 modulo 151. And this means the fourth equation will be 4x, right? Yes, 4x congruent to 125, which equals 104 modulo 151, because 225 is bigger than 151, so we subtract it, we get 104, and it's easier to work with smaller numbers. So then the third equation will be the next that we will subtract from. This is the third equation, the 9x minus 68, minus the 4 equation, and times, and it's 2 times, because 2 times 4 is 8, which is smaller than 9, and we can't divide more. So, and it will be the fifth, and it's 9x minus 2 times 0, 4x congruent minus 68 minus 2 times 104 151, and the fifth one will be so the fifth equation will be x, because 9x minus 8x is 1x, congruent 200, it will be minus 276, which equals to 26, because we can just add 251 twice and we get 26, and it's an easier form. And we got to 1x, so from that we get that the numbers that are that give you 34 when divided by 302, and before that multiplied by 202 is those numbers that are like are in this form. So x times 151 plus 26. These are the numbers that will fit our category. So when multiplied by 222 gives 33 as a remainder when divided by 203. Why is that? Because sorry, I messed up. So not 22 but 26, because that's what we got from here. 36. So why these numbers are why is it true? Because whatever you put here, it will always give you the right answer. So, and the other question was between 0 and 301. So to calculate which numbers are between 0 and 301 that fit this, we put first 0 to the x, then it's 0 times. So give me a second. So if x equals 0, then 0 times 151 plus 26 equals 26. So this is one of our numbers that's the solution, and let's say x was 1, then from this 1 times 151 plus 26 equals 177. This is the other number, and then x equals 2. 2 times 151 plus 26 equals 328. This is bigger than 301. That means that this number is isn't a solution. So the final answer is that 26 and 177. So yeah, what you need to learn, basically you need to learn the Euclidean algorithm. I will write down the formula for you in a minute. This is obvious. This was obviously a practical application of the formula, but without numbers and with, well, letters. It looks something like this. So A equals to Q0 B. Obviously we got B, A and B is something that we already had in our hand. So this is the two numbers that we want to find the smallest common divisor plus remainder 0. All right, then B Q1, so something that we multiply the R1 R0 now plus R1. Then R0 equals Q2 times R1 plus R3. It goes all the way until you get Rn minus 1. So n times minus 1 equals Qn minus give me a second. So n minus 1 n plus 1 no, sorry. So you continue this until you get somewhere where the R will be 0, and then you check the one before that. So this is how you use it. So these are the R's. These all are the R in this this equation, and you go until you find 0, and you take the one remainder before that. So in this case 2, and that will be the smallest common divisor. And when you divide the original equation with that number with the congruence 2, you write down the new equation as this, and you take an also true equation, it's like x times the modulus congruent 0, it will be always true, it will always be like this. So m times x congruent 0 modulo m, this will be always the other equation, and you start subtracting each other until you get to 1. What? No, to here. So until you get to x, and that will be your answer. I know it might sound a bit complicated. For the luckily for the Euclidean algorithm, there are quite a few videos too, and also sites. So yeah, I suggest learning the these kind of algorithms, because they will ask you one of them, and you need to solve them like this. So every step need to be written down, otherwise they won't give you the points, even if it's good. Any questions?
I have a question.
Yes.
Why is it R3 and not R2 in the third line?
Because I messed up the numbering. That's the only reason. R2. It should be R2. R2.
R2, thank you.
You're welcome. Any? All right. If there is no other question, yeah, I will go to the next one. I suggest looking back on this. The video will be uploaded, and also probably this whole file. So yeah, I think this will be the last one, and it will be geometry. So this was our last year's. This was from last year's midterm from us, right? Plane equation which contains which has a equation and does not contain f. A and f is A and f are lines. So yeah, right. And we need to find a plane, a plane's equation. So first, A is equals to x minus 1 per 2 equals 5 minus y, and z equals 2. And f is x per 7 equals 1 minus 2y per 12 equals 8 minus z. So these are two lines, and these are the equations in the space. So not in 2D, in 3D. So what do we know? We know that we need to find a plane equation. For that we need a normal vector and a point. which is on the plane. And we also know that the plane contains A and doesn't contain F, and has no similar points. So it doesn't. So they don't have. Not a single point of them is common. I didn't write that down, but basically, yeah, I forgot. So, what can we find from, for example, A? We need to transform this equation a bit. So, usually, a line equation in 3D looks something like this, that x minus x0 per u1 equals to epsilon or y minus y0 per u2 and equals z minus z0 per u3. And from this, n is the normal vector and n has the u1, so the x, the u2, which is the y, and the u3, which I messed up again. So this is the normal vector, and you divide by them, and the x0 epsilon 0 z0 is basically a point on the line, so it's a point. So we need to so this is the basic or basic equation. So the common. So using this knowledge, we transform A to look something like this. What do I mean by that? So we don't need to do anything about x minus 1 per 2. It looks just like that. This and this looks similar, so it's in a right form. But 5 minus y is not the right way. So we write it down like this: y minus 5 per minus 1. Why do we do this? 5 minus y equals minus 1 times y minus 5, and we divide it, so it goes here, and that's why we can do it something like that. And this form looks just like this form. So 5 is y0, which is a point on the line. Minus 1 is the not normal vector. Line doesn't have normal vector. Direction vector. So direction vector. So now this also looks like it needs to, and yeah, you can't really do anything with z equals 2, because it's like a must. It's it must look like that. But from that, you can find a point that is on the A line. That means that, for example, P is 1, 5, and 2. How do you know it's true? You start to put them in the places. So 1 to here, to x, and 1 minus 1 per 2 is 0 per 2, which is 0, equals to 5 minus 5 per minus 1, which is 5 minus, which is 0 per minus 1, 0. So this is true if you use 1 and 2, and z is given, so it will always be 2. So P is on the line, and we can also calculate the normal vector for A, which is 2 minus 1, so 2 minus 1, and 0 because 2 is a constant number. And we now do as a point on A and as normal vector. Now we do it the same for F. So transform F. Because F right now looks like this, and it also has it's not very similar to this this one, but X can be right now like X minus 0 per 7. This doesn't change this, so the meaning is similar, but now it looks like it should equals to y minus 1.5 per minus 6. Why does it look like this? We had to divide by minus 2 because here the epsilon is with the minus 2 multiplication. So we divided by minus 2. It's y minus 1 divided by minus 2 is minus 1.5. 12 divided by minus 2 is minus 6. So we got this. This also looks like how it should. So epsilon minus epsilon 0 per u2, epsilon minus epsilon 0 per u2, and the last one is z minus 8 per minus 1, just like we did here. We divided the whole by minus 1, and we got z minus 8 per minus 1. So now the F equation looks like it should. So we can find a point which is like 0, because 0 is here, 1.5, and 8. And the vector F, which is the direction vector, 7, 6, and minus 1. So we have a direction. We have 2 direction vectors and 2 points. What can we do with that? So we know that A contains Ash is the plane. So Ash plane contains A, but not F. What does it mean? So Ash plane must be parallel with A, because it contains, so every point of A is in the plane, so it must be parallel, otherwise somewhere they would diverge. So it's parallel, and also it doesn't contain any point of F, so F and Ash must be parallel, otherwise somewhere they would meet and there would be a common point, which there isn't, so both of them are parallel. So that means A and F H plane. And from that, we know that the H's normal vector, which is n, is perpendicular. So it has so 90 degrees to A direction vector and F direction vector because of the rules. And because they are perpendicular, from that we know, because from scalar multiplication, that V A times n and V F times n both will be 0. That's from scalar multiplication. Two scalars that are perpendicular will be 0. And from this, you calculate that 2a minus b equals 0, and 7a minus 6b minus c equals 0. How do you know that? You look at the normal the direction vectors, and it's basically 2 1 0, so that's not here. 7, so it's minus 1 0 7 minus 6 minus 1. This is how we find this is how you multiply scalar. But from this you transform it, so b will equal to a and c will equal minus 5a. You can transfer it in a way, and now you can choose any a. So let's say equal 1, then b equals 2 times 1 equals 2, and c equals minus 5 times 1 equals minus 5. Messed up. So minus 5. So n will be 1, 2, minus 5. This is one of the possible normal vectors. And you also need a point, but we have a point because A is on the plane, and we already calculated that P1, 2, and 5 is part of A, so it's part of the plane. So 1, 5, 2, sorry. And from here, the plane's equation is x plus 2 y minus 5z equals 1 times 1 plus 5 times 2 plus minus 5 times 2, which is 1. So this is the normal vector x, so the first coordinate, and this is p, so the p points x coordinates, so x0. This is n y, so the normal vector second coordinate, and epsilon 0 and this is nz, so the third coordinate of the normal vector, and this is z0, and obviously it's x, y is y, z is z, and this is x0 as it's epsilon0 and it's z0. So this is how a plane's equation must go. But yeah, the ending is x. Final solution is x epsilon 2 epsilon minus 5z equals 1. Yeah. Is there any question? All right. So this call will also end in 9 minutes. And also I'm out of those exercises that I prepared for this consultation. Do you have any question with any of the exercises we solved, or do you have an exercise that you want to solve in like the remaining few minutes? All right then. Then in the last, then a few tips for learning. You in ITC I found the ITC website that is for your course, and on the bottom of it there are last year's and the years before midterms. So yeah, midterms from previous years. I suggest checking them out. Usually there are very similar kind of exercises in them. So it's worth solving a few of them, at least, like the last year's and the last year's retake and the and 2021's first midterm and the first midterm repeat. So yeah. So is there any other question? All right, then I think we will end today's consultation. Oh, you can say. Don't.
Can I ask a question from
Yeah. You can, of course.
The question goes like this: how many integers are there between 1 and 1000 which have equal number of even and odd divisors?
Sorry, repeat. Could you repeat, Jesus? Could you repeat it, please?
Yeah. How many integers are there between 1 and 1000 which have equal number of even and odd divisors?
Whew. 1 and 10,000 equal number of 1000. All right.
Even and odd divisors like 2, 6.
Oh. I don't really know right now. I don't even know how to start this solution. So I will look into it
Maybe
and
I can
upload
help
it.
you,
Sorry,
but I don't know how to solve it.
could you
Maybe
repeat?
I can tell you the starting as the teacher, like solve it.
Is this from a previous midterm?
Hmm.
I'm sending its solution maybe in the group. You can see from there and you can tell us how to like, because I don't understand it. Like,
I right now I can solve it. I will look into it and upload the solution to the group if it's all right for you.
okay.
All right then. So then I think that was for today. Thank you for coming and good luck for your midterm and good luck preparing for it.
Thank you for your time.
Thank you so
Thank you.
much.
Sorry, please. Can the solutions also be sent to the other group?
Yeah,
The
I
one Messenger.
yeah I will send to your group or send someone to send to your group.
Okay. Thank you so much.
You're welcome and goodbye.